For resampling, we're actually physically resampling the input data in a random fashion. What we found, for whatever reason, is that this did a better job than changing the seed numbers, and I might need to talk to some Salford people about that. But really, again, this is a technique to reduce overtraining. Remember, what we're doing is we're making a series of decisions based on the validation data set. And when you do that, sometimes you can lead to a certain amount of overtraining. So it's important, by resampling, we're looking at different validation data sets at each step. So we're avoiding a lot of this overtraining. The peak performance for this technique was actually arrived at just 25 variables, a very small number of variables when you consider that we started out with 228 variables. The ROC of the learn was 0.768. The ROC of the test was 0.758. So again, with variable shaving, we were looking at models that were performing at 0.74. So this is really, providing us with, some extreme amount of lift in this case. Okay, so again, same graph. What we have here is, a line at 0.736. That's the model without any variable restrictions. The red line, again, is the learn ROC. The green line is the test ROC. What you can see is when we grow with this method, we're growing from the left side to the right side. And you can see that a lot of the performance on the test is really maximized once we reach 110 variables. There is some increase after 110 variables, but it's not that great. And really, one of the biggest things here that you'll notice is really this peak at variable 25. We reach maximum performance right here. You'll also notice that this pattern is a lot more probably up and down than the other than the importance pattern. Again, it's a very highly interactive world, and sometimes when we're introducing new variables, there's some important interactions that really lead to these, increases in performance and thus these bumps. Some of the variables at the end, you can see a big drop off on the end. These are really problematic variables that this method was really able to identify. These are variables that were very highly important but led to a significant amount of degradation in the models. In this case, I believe it was just a series of higher order categorical variables, nothing that you wouldn't want to experiment with. I think they were 10 degrees of freedom variables, but taking them out definitely reduced the overfitting dramatically. Are there any observations here? Anyone? Any questions or? Mm-hmm. It depends how you measure it. Mm-hmm. Okay, 0.758 versus 0.736. In this case, again, I think a good. No, it's between. No, actually, this green line's at 0.736, and we're talking about the distance between. Sorry. The distance between this point and here, right? Yeah, with just leaving up to the natural variable selection of TreeNet. 228. So we actually started the case, yeah. It's really hard measurement. I wouldn't even think that taking the percentage difference between the two ROCs is a good measure. And truthfully, I'd want to say another thing. A good data miner could definitely produce a model much better than this. A talented data miner is going to be able to really identify these types of variables and basically do something about them. So it's hard to say. truthfully, in our world, we might see, at a 30% depth of file, we might see a 1 to 2% improvement in the number of responses generated. So, I mean, that's a huge improvement in the direct mail space. Mm-hmm.
So it seems like you're saying from this that there's a systematic overfitting treatment between letter from is that, or did you force TreeNet to
It's
do everything initially in an unnatural way?
That's, I definitely didn't force TreeNet to include anything. That's, a tough question. And truthfully, well, yeah, that's a tough question. But I mean, TreeNet does naturally does an amazing job at selecting variables. The improvement that we're seeing here is, if you compared it to the improvement with feature selection on, logistic regression, it's really minimal. But, in our world, it's a huge improvement.
So, I mean, is your assumption that because the individual trees are
Mm-hmm.
that top-down manufacturing, by excluding certain variables, we prevent trees from taking the first or second split of one of those
Yep.
variables that, from a greedy point of view, looks like the right way to go, but in the long run, it's not that.
Exactly. And that happens a lot with the two types of variables, categorical variables and the composite variables. They're all very heavily used in the TreeNet trees. And that also pushes out a lot of maybe possible valuable interactions too, when there's certain variables that just dominate, basically. There you go. Improve on the cart, or okay, yeah, I was okay. So that had to do with using TreeNet importance to select which variables are inputted into cart. Mm-hmm. I think that'd take further testing on my end. I'm not really sure if the best cart would be, just gain from those 25 variables. It probably wouldn't. So that would take some testing. I'm not sure where the optimal point would be. Are there any other questions or comments? Okay, so next slide, backward selection. So this, same stuff as forward selection. We're still decisioning on ROC on the validation data set. We're resampling rows after each decision point. Peak performance here was attained after 71 variables. So it did in this instance, did a much, worse job at trimming down the variable scope. And there's a lot of reasons for this. I'll get into those later. 23,600 models were required to identify this set of variables. So 71 out of 228 variables took a lot of models to evaluate. Another point that I want to make is these models were also slower. TreeNet's a lot slower when you include a large number of variables. So each iteration actually took longer in this case. And there's lots of good techniques for getting around running this many models. The ROC on the learn was 0.761. ROC on the test was 0.760. Okay, so this graph looks decidedly different than the earlier ones. The increase in performance is more steady on the learn ROC, and again, the peak occurs much later. At 25 variables, it really underperforms what we saw with forward selection. And this really highlights to me one of the difficulties in doing what we're doing. A lot of the important decisions are being made, in this area in backward selection. And with our testing procedures, the I guess the differences are very minor when you're dealing with removing one variable from 228 variables than if you're removing one variable from 40 variables.